Hey guys, it's Mrs. Everhart. I am going to go over with you some notes on page 32. I'm going to do the first four examples today, and then the last four examples on the page will be on Monday. Tonight's homework, the first part of it, 21 to 29 odd, is just using your unit circle and, figuring out the missing piece just for angles that are in the first quadrant. And then 67 to 71 odd are going to be just like the ones I'm going to go over with you right now. You're going to find all of the angles, not just quadrant one angles from the unit circle. Okay, so how I think about these, the directions say what we're doing is finding angle measures for exact values. So we're kind of going backwards from our unit circle. Before we were finding the cosine of 30 degrees, the sine of 30 degrees, and so on. Now they're giving us the actual ratio of the sides of the triangle, and we are to come up with the angle. Okay, so the first thing I want you to think about, and I kind of do this in stages. The first thing I think about is what family does it belong to? And from knowing what we know about the unit circle, hopefully at this point you at least have a good grasp on, I call these the cheater points. I memorize them. We know how we got them from going over special right triangles in our unit circle. But if I have those handy at the top of my paper, remember I don't memorize the pi over 3, I just reverse the pi over 6. But I look at it and I say, okay, the cosine, our unit circle is this wonderful shortcut. The ordered pairs on the unit circle, if they are truly on the unit circle, the x-coordinate of that ordered pair is always the cosine of the angle, and the sine is always the sine of the angle. The y value is always the sine of the angle. So I look at this and I go, okay, cosine is root 2 over 2. Cosines are the x's. I know it's not the pi over 6. It's the pi over 4 family. The second thing I'm going to think about are where are cosines positive? Because this cosine is positive root 2 over 2. So this is where I'm going to think about all of the quadrants, and I can do this one of two ways. I'll show you two ways to do it. Cosines are positive where x's, because remember the cosine was the x, are positive. So that's one way to think about it. So we know cosines are positive or x's are positive in quadrants 1 and 4. There's another little trick you can use. All students take classes. In the first quadrant, all of the trig functions are positive. In the second quadrant, the sine and its reciprocal are positive. T is for tangent, and its reciprocal are positive. So this is where they're all positive. And then the cosine and its reciprocal are positive in the fourth quadrant. A for all, students for sine, take tangent, classes cosine. Okay, so however we do that, we figure out the two quadrants that the answers are going to be in, and then we have to answer the question. So I know I'm going to have an angle in quadrant 1, I'm going to have an angle in quadrant 4. Now I can use my road map if I want. I know the quadrant 1 angle is just going to be pi over 4. They also want us to answer this in degrees as well as radians, so I want to include the 45 degrees. And then if you're using a road map and you're in pi over 4s, or if you're just good with the unit circle at this point, we'll know that this is 4 pi over 4, this is 8 pi over 4, this is 6 pi over 4. So the pi over 4 angle in quadrant 4 is 7 pi over 4, and 7 45s would be 315. Okay, and that's what we do to get the answer, and here's our 4 answers. Okay, so let's look at the second one. Very similar, except for now this gives us the cosecant. So I'm going to look at those cheater points. The cosecant I have to know is the reciprocal of the sine. Okay, so I'm going to write this as sine of theta. If the cosecant's root 2, the sine is 1 over root 2, which remember that will rationalize to root 2 over 2. So now I'm going to look at my cheater points and figure out what family does it belong to. Now remember the sines are the y's, so I'm looking to see which family has a sign that's root 2 over 2, and I'm back to my pi over 4 family. Okay, so that's my first thing that I'm going to think about. It is the pi over 4 family. The second thing I'm going to do is figure out where cosecants. I'm much better with sines than cosecants, and they're both going to be positive in the same quadrants and negative in the same quadrants. So I'm just going to think about sines or y's, and we want to see where the y's are positive. Or we could use that all students take classes. All trig functions are positive in quadrant 1, sines and cosecants in quadrant 2. Okay, so we know that it's going to be quadrant 1 and quadrant 2. And then we're going to answer the question and throw the pi over 4 angle in quadrant 1. Well, that's just going to be pi over 4 or 45 degrees. And then we want to do the same thing in quadrant 2. Remember, if you need your road map, it's easy to figure out that'll be 3 pi over 4. 3 45s, that was a 4, is 135. Okay, so these are a little bit tougher because we're going backwards, but if you go through these steps, you should be okay. Now the third one is the secant. We are probably much better with its reciprocal. So we're going to have a little bit of work to do here, but I know that's the cosine, so I'm going to flip that, and then I'm going to try to simplify it. I have negative 3 root 3 over 2 times 3. This is going to give me negative root 3 over 2. Okay, so my first step, I want to see cosines of root 3 over 2. So I'm going to go back to those cheater points. Cosines are my x's. So I'm going to look at those ordered pairs and think which one has an x value that's root 3 over 2, and that's my pi over 6 family. Okay, so that's the first thing I'm going to answer, pi over 6 family. Second thing I'm going to answer is where are cosines negative? So not where cosines are positive. So if we use all students take classes, we know that they're positive in 1 and 4, so therefore they'd be negative in 2 and 3. Or cosines are x's, and we're looking at where the x's are negative. So then our third step is to go ahead and put that family of pi over 6's, and we can use our road map. If this is 6 pi over 6, then in quadrant 2, the pi over 6 angle is going to be 5 pi over 6, or 5 30s. And in quadrant 3, it'll be 7 pi over 6, or 7 30s. Okay, and then the last one, number 4. This one is tangent is negative root 3 over 3. So again, I'm going to go back to those cheater points. Tangent is y over x. Okay, I know right away for pi over 4, if I put the y over the x is just 1, since they're both the same. So it's not going to be that one. It's going to be either the pi over 6 or the pi over 3. So I'm going to try the pi over 6. I'm going to take the y, which is a half, divided by, instead of a complex fraction, I'm going to make it divided by. So it's 1/2 times the reciprocal of root 3 over 2, which is going to be 1 over root 3, or root 3 over root 3. So it's not going to be that one. So I am going to guess, I should probably check it, however, that it is going to be the pi over 3. So if I would take that one and do the y of root 3 over 2 divided by the x times the reciprocal, that's exactly what it is. Okay, so this family is the pi over 3 family. Now tangents, all students take, that's where they're positive. We want where they're negative, so they'd be in the other two quadrants. Or another way to think about it, since you did y's and x's, the x and y signs have to be different so that when you divide them, they'll be negative. So x's and y's are both positive in quadrant 1 and both negative in quadrant 3. So tangents will be positive in those two quadrants. So we're looking at quadrant 2 and we're looking at quadrant 4. So now we want to throw those angles. So we're going to throw that pi over 3 angle. So we could do our road map, 3 pi over 3. So I know in quadrant 2, that's going to be 2 pi over 3, or 2 60s. And then 5 pi over 3 in quadrant 4, 5 60s, or 300 degrees. Okay, so we'll look at a couple more tomorrow. Tomorrow's will be more quadrant angles, because it's going to get a little interesting with zeros and undefined. But this is enough information